Hi, welcome back to Unit 11, and today is day 2 on box and whisker plots and dot plots. You will want your graphing calculator today because what we're going to start with is creating something called a box and whisker plot. You may remember doing this in middle school. I believe it's part of the 7th and 8th grade curriculums. But anyways, we are going to use our graphing calculator to sort of organize our data. In a recent year, the 12 teams in the Western Conference of the NBA had the following number of wins listed below. We don't need to put them in consecutive order in any way. We're going to use our calculator. We are going to type them in our list just like we did yesterday. So all of these numbers are going to go in L1 in our calculator. And we are going to find our 5-number summary just like we did yesterday. So let me bring up my calculator. I'm going to type these values in my Y1. So stat, edit, arrow up, clear, enter. So we want to clear out anything from yesterday or from your homework. And we're going to type all of this information in list 1. Remember to press enter in between each entry. All right, and then just like yesterday, you're going to press stat, arrow over to calculate, hit enter for option 1, clear out if there's a frequency list, we don't want one, go down to calculate and hit enter one more time. For us to make a box and whisker plot, we don't need the mean, which means we don't need X bar. We need that second list. So scroll down in your calculator so that we can get that list. And those are going to be our 5 critical points for our box and whisker plot. So if you can make a list right here and fill in the blanks, our minimum is 17, Q1 is 26, Q2 is 45, Q3 is 53, and our maximum is 62. Those 5 critical points that we call our 5-number summary or central tendencies are when I go to graph, I make these little toothpick lines. I call them toothpicks. They're vertical lines that represent those 5 numbers. The inner 3, so going from our lower quartile, which is Q1, to our upper quartile, which is Q3, that's going to be the box portion. And then the whiskers go out to the maximum and the minimum to show the full range of our data points. So when you're making a box and whisker, you need to have a scale that is evenly distributed, and then you're going to mark your 5 points. So I'm going to count each tick mark as I'm going to skip a line and do 5, 10, 15, 20, 25, 30, 35, 40. I came up with this scale because it was the one that I felt like was the best fit for the data that I have. Oops, 65, not 62. Because the lower end starts at 17 and the upper end has to go all the way up or beyond 62. So 17 to 62 is our span. So let's make our little toothpick marks. So we have a 17, we have a 26, we have a 45, we have a 53, and then we have a 62. The middle 3 are what I'm going to connect to make the box, and then just draw a connector for our whiskers, so to say. Now, since I'm sort of creating these separate segments, I'm going to use a different color here. Let me use red. It's kind of breaking it up into 4 sections. And those 4 sections, hence the name quartiles, it's breaking up into 4 separate quartiles. 25% of the data is going to fall from the minimum, which is this point, the minimum of 17, to the Q1, which has a value of 26. Another 25% of the data is going to fall between the Q1 and the median, which is 45. Another 25% of the data is going to fall between the median and Q3, which is 53. And then the last 25% that totals 100% is going to fall between Q3 and the maximum point, which is 62. So that's how the information is sort of organized into quartiles or quarters. So 25% for each sort of section of a box and whisker. So each part of a box and whisker contains 25% of the data. So using this information, we're gonna try and answer some questions about other box and whiskers, or maybe create some more on our own. So using the data on annual deer population in a forest, Nick found the following information. The 25th percentile, which is we know is Q1 now because each quartile is 25%. The minimum is 8. The 50th percentile, otherwise known as the median, is 15. The maximum is 27. And the 75th percentile, that's going to be our Q3, is 22. Let's create a box and whisker. So we have to go from the lowest of an 8 to the highest of a 27, it looks like, as our maximum. So you can count by 2s, you can count by whatever you want. I think I'm going to count by 2s. So let's do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. I guess that's all I needed. I guess I could have counted by 1s, but this is fine. All right, let's make our toothpicks. So my first toothpick is going to be at our minimum of 8. Our next one is Q1 at 12. Our middle is at 15, so that's going to be between there and there. Q3 is at 22, which is on that line, and then our maximum of 27, which is going to be in the space here. And then connect your inner 3 and draw your outer. So the way a box and whisker, if this was ever asked on a test or a Regents, you would need to either list these numbers above so that somebody reading your graph knew what those values were, or you can label the values above like I did on the last example where I labeled the numbers under it. You could do it that way as well. So you either need to list them separately or list them on the graph itself. Let's try the next one. It says the following test scores from Mrs. Gray's math class are shown below. Construct a box and whisker plot to display these data. So again, we're going to go back to our calculator. We're going to do a lot of stuff in our calculator today. We're going to type those in L1. Hopefully you guys are getting the hang of it. I know if you're listening to this, then that means I'm not there to teach it to you, but it's the same thing over and over and over again. So hopefully repetition is helping you learn it. So I'm just typing in these data points in our list. I'm going to run the same regression that I have this whole time, which is one variable statistics. Hopefully I'm not missing any numbers. There's all my numbers. So press stat again, arrow over to calculate, option 1. And our 5-number summary is on our second page. So there is our 5-number summary. So I'm going to list it off to the side this time. So our min is 66. Q1 is 72.5. Q2 or median is 85. Q3 is 90. And our maximum point is going up to 95. So let's make our line. So 66 would be about here. 72.5 is going to be halfway. 85 is on that line. 90 has its own line. 95 has its own line. And we connect our inner and draw our whiskers. Cool. All right, number 3. Sorry. 20 of Mr. Greco's physics students recently took a quiz. The results of this quiz are shown in the following box and whisker diagram. Assume all scores are whole numbers. So if we look at our scale that's provided here to get from 50 to 60, I believe this is counting by 2. So this would be like 52, 54, 56, 58, and then 60. So that means this minimum is at 53. Our Q1 looks to be like it would be at 64. Our median is just to the right of 70, so that must mean our median is 71. Our Q3 looks like it's going to be around 76. And then up here is 84. That's going to be our maximum point. So let's read the questions and see what we can learn from, or let's see what they're asking us. What was the median score? Okay, we got that. The median was a 71. What is the range of scores? Okay, range is maximum minus minimum. Mr. Greco regularly sets the passing grade on his quizzes to be the score of the lower quartile. What is the passing grade of this quiz? All right, so the lower quartile is Q1, so he considered 64 a passing grade. What percent of the quizzes ranged from 64 to 76? That is 2 boxes worth, so that would be 50% of the data of the scores fell between Q1 and Q3. And then last but not least, Mr. Greco considers mastery level to be an 80 or higher. Approximately what percent of his students got mastery? This is kind of tough to say because we definitely know that 25% of the data is in this range, but we can't really say that that's, even though that appears to be halfway, that half of the students fit in there. So we can say somewhere below 25%, but we cannot say 12.5%. And the reason being is all the test scores in that upper quartile could be clustered around this score, and then there could be just like one kid that got an 84 or something like that. That would not mean that 12.5% got above an 80. We don't really know what's going on as far as the scores within that quartile, so that's why it's somewhere below 25% of the scores, but I'm not really sure how many. All right, let's take a look at a couple more questions. The speeds in miles per hour of 24 cars on a particular road are recorded below. Answer the following. What is our interquartile range? Let's look at our scale. 2, 4, 6, 8, 10. All right, so this looks like 24, 30, 2, 4, 6. So this would be 37, 42, and then it looks like our fastest is about 45. So if I want my interquartile range, that is Q3 minus Q1. If I want the fastest, that's the maximum speed on this road that we recorded, which would be 45 miles per hour. The median is the one in the middle. And then it says, are more people speeding or going slower than the speed limit if the speed limit is 36? So 246, here is our speed limit, which is a weird number to have a speed limit set at. Well, because this piece, I should keep the red out, this piece and this piece account for 50% of the data, and that 50% is above the speed limit. We're going to say more people are speeding because more than 50% of the people are above the speed limit. So more are speeding, more than 50% are above the speed limit. Are above the speed limit. Cool. Number 5, the data given represents the number of hours spent on the internet in a week by students in a math class. Which box and whisker plot represents the data? Okay. We are looking for one that has a minimum of 5 and a maximum of 19. Let's see if we can narrow down some results in that way. It looks like I can at least get rid of 1 because that has a minimum at 2. Everything else looks like it's going to be from 5 to 19. So we're going to need to type this one in our calculator. So what I'm going to do is I've narrowed it down. I'm going to pause. I would like you guys to try this one and see if you can match the box and whisker, and I'll tell you what the answer is after. Okay, hopefully you had some time to calculate your 5-number summary. We already knew what the min and max was, but hopefully you discovered your Q1 is 8, your Q2 or your median is 10, and your Q3 is 17, which should be a perfect match with option 2. Number 6, quick, easy question here. In the box and whisker, what is the second quartile? That's your median. That is 30. Easy peasy. The accompanying box and whisker plot represents the scores earned in a science test. What is the median score? There we go again. Median, middle, that's the middle toothpick there. That would be right here. Number 8, the box and whisker plot below represents student scores on a recent English test. What is the value of the upper quartile? We know that, otherwise known as Q3. Q3 is the toothpick right here. If it's counting by twos, then I would say that that's a score of 84. All right, so that's great if they give me a long list of numbers like number 5 did, a long list of numbers. But sometimes when we have like repeats, like this one had repeat 17s, this one had repeat 19s, this one had repeat 9s. Sometimes if we have things that are repeated multiple times, like even more than just 2 or 3 times, it's easier to organize it in something called a frequency table. And that's where we actually are now going to have something put in L2 as a frequency. So, grabbing your calculator, what we're going to be doing is putting our scores, that's going to be in the first column, still in our list number 1. But now that there's a frequency list, what that means is this 4 right here tells me that there are 4 8s. So if I listed this out, it'd be 8, 8, 8, 8. There are no 7s. There are 2 6s, so that would be 6, 6. There are 6 5s, so that would be 5, 5, 5, 5, 5, 5. So instead of typing all of those things in, I am going to use a frequency list. So grabbing those calculators, bringing that back out, stat, edit your list, just like we were, stat, edit, clear out whatever our old stuff is, and we're going to type the scores in L1. So 8, 7, 6, 5, 4, 3, 2, 1. Go over to list 2, and this is where we're going to put our frequencies. Now they have to correspond, so 4 has to go with the 8, the 0 has to go next to the 7, and so on. Don't skip it, even though it has a 0 in that list, don't skip that number, because they should line up. So our 2 lists should be the same length. We're going to press stat. We're going to arrow over to calculate. We're going to still choose option 1, but now we actually do want something to be where it says frequency list. So arrow down so that your cursor is in that spot. Now our frequency list we put in L2. So that means we have to tell our calculator by pressing second and then number 2. See right above it in blue, it should say L2. So press the number 2. That should pop L2 in the frequency list. Go to calculate, hit enter, and we are able to not only figure out our average for that frequency, but we can also figure out our 5-number summary based on these frequencies too. So let's list them all out and we'll create a quick box and whisker plot. So the median is 4, the average is 4.4, my Q1 is 1, oh, I lost my minimum. I'm going to throw that in there. I don't know where that is, but that means it's not in your packet either, so write that in. 3, 4, Q3 is 5.5, our maximum is 8, and now that we have all those numbers, we can figure out our range is 7, our interquartile range, oh, that should be a minus, not an equal sign, sorry, minus 3 is 2.5, and now let's talk about mode. Mode used to be the number that repeated the most, and it still is. But now the easiest way to figure it out is whatever number is the biggest in the frequency, that tells you which score has repeated the most often. So since 3 is repeating itself 7 times, 3 would be the mode. All right, I'm going to skip example 10 because it's the exact same concept, okay? I'm going to move down to our last concept. I think we've done enough box and whiskers today, but you would just take your points and create a box and whisker just like we had all lesson already, so I'm not going to be too concerned about that. The last thing I want to talk about today is creating a dot plot. Now a dot plot does show up in real life quite often. It's a nice way to organize data so you can see trends, you can see if something is maybe skewed. You can easily read the mode once you have a dot plot created. It sort of looks like a bar graph without the bars. That's kind of what I think of it as. So on February, blah, 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 they recorded temperatures. Those temperatures are given in degrees and they are shown below. Construct a dot plot for each set of the data. I'm sure you'll be very happy to know we do not need our calculator for this part unless it asks us to calculate something. So this very first one, part A, I don't need a calculator. I'm just going to create dots. So the temperature of -10 on our scale here, put a little dot, or sometimes I like to use X's, so I'm actually going to erase that. I'm going to use an X. 15 gets an X, 14 gets an X, 17, we had another 14, we got another 15, we have a 16, we have another 15, 13, 14, 12, 11. And so what's kind of nice is once you have all your dots listed, you can kind of see like, oh, it would have peaked sort of like in around this temperature, somewhere around 15 or 14 degrees. You can kind of see your range pretty easily, your max to your min pretty nicely, your modes, and so on. So number 2 says the dot plot below shows the price of a Blondberry jacket at 10 different stores. Interesting. Find the average and the median of the jacket prices. So we have 120. There's a couple different ways you can type this in your calculator. Our scores, or our prices, I should say, the jacket price versus how many they have. So I'll put like quantity. Or frequency, actually, that's probably a better word since this is talking about frequency day. I'll put frequency. We have $20, and there's one dot at $20. $30, there's none. So if you don't want to include that data point, that's fine. Sorry, a horn was honked in the neighborhood, and that means we have to bark. 4, there are 3 $60 jackets, and there are 1 $70 jackets. So if you want to type it in this way, that's fine. If you just want to type in 20, 40, 50, 50, 50, 50, 60, 60, 60, 70, all in L1, be my guest. Totally fine. You can do it either way. I'm just going to tell you guys the outputs unless you really want to cross-check me. Hopefully I typed everything in right. Find the mean and find the median. So the mean is your average, that's your X bar, and the median would be the middle. Now I could have figured out the middle by working in my dots like from the outside in. So this dot and this dot gets rid of this dot. Bada bang, bada boom, bada bing, bada boom. So clearly 50 is going to run us down the middle. And that would be confirmed in my calculator. 50 is also the mode. That's the one that has the highest stack, so that is going to be definitely our mode. But once I average these out, the average ends up being 51. Because more jackets are a little bit more expensive. Most of the data is up on this end, so it's sort of tipping the mean a little bit upward. All right, last example of our notes for today. The dot plot shown below represents the number of pets owned by students in a class. Which statement is not true? All right, which statement is not true? So we are going to try and figure out the median, the mean, the interquartile range, and if there are outliers. Now, I'll be honest, we learned how to calculate for outliers yesterday. This definitely, I don't have to waste my time doing that calculation right now. There is definitely no outliers. That is true. There are no outliers. If there was an outlier, it would be something like boop, like that dot would be like way off, and it would be super obvious that that's an outlier. So that's actually a true statement. We want the one that's not true. So let's find the one that's not true. So yet again, you could list all of these dots all in L1, or you can organize your data by saying, well, there are 2 zeros, there are 2 1s, 1, 2, 3, 4, 5 2s, 5 3s again. There are 3 4s, 2 5s, and 1 6. And then you would put this in L1 and this in L2 and calculate your stuff. Just to save us a little bit of time on this video, I'm going to tell you that the mean is 2.75. The median is 3. My Q1 comes out to be a 2 and my Q3 comes out to be a 4. So if I have to figure out my IQR, the difference between those would be also a 2. So let's see what's true. The median is 3. That's true. The interquartile range is 2. That's true. Uh-oh, here we go. The mean is not 3. That's the one that's untrue. The mean was 2.75. Okay. Hopefully that all makes sense. Feel free to re-watch if you need more time with the calculator steps. They are typed out in your packet. And you'll be doing homework number 2 tonight.